Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3 for May-June 2023 for paper 3-1, and this is part 1 for questions 1 to 6. Question 1, solve the equation. This one, it is an equation. It is an exponential equation. Correct your answer to 3 decimal places. This equation here, I can see an e, which is a negative, so I can write it as e here down in the denominator, which is equal to 5. Then I can multiply everywhere by e power 2x such that I eliminate this denominator here. So I'll get 3, then e power 2x squared, then minus, this will be a 4, and then here 5e to the power of 2x. So I can bring this one this side, and then we have 3 e to the power of 2x squared minus 5 e to the power of 2x, then minus 4, which is equal to 0. So this is a quadratic equation. Okay, this is a quadratic equation in e to the power of 2x. So I can solve it using the quadratic formula because it cannot be factorized. So e to the power of 2x is equal to minus b plus or minus to the square root of b squared minus 4a, then c. Then we divide by 2a. We have this 5 becoming positive, then plus or minus 4 times 3, that is 12. 12 times 4, that one will give us 48. So 48 plus 25, that one will give us 73. Remember, a negative times a negative, that's a positive. Okay, so we shall have square root of 73, then out of 6. Now, I'm only going to take the positive value because the exponential, there is no value I'm going to give to this one here, and then it ends in a negative. So e to the power of 2x is going to be equal to 1 plus the square root of 73 out of 6. To get x, I'm going to introduce logarithms. So natural log of e to the power of 2x, this one is going to be equal to natural log of 1 plus the square root of 73 out of 6. And you know that this one can come here using the rules of logarithms. And then we shall have 2x, then the natural log of e, but natural log of e is a 1, so I can just write 2x, which is equal to the natural log of 1 plus square root of 73. Then we divide by 6, and then our x becomes a half the natural log of 1 plus 73 out of the 6. So if they wanted the exact value, that would be the one, but they want the answer to 3 decimal places. So what do we get when we put this in the calculator? Sorry, everywhere here I put a 1, I'm supposed to be having a 5 here, I'm supposed to have a 5 even here, here, and also here. So we have a 5, pardon me, here, and then a 5 here. So what do we get in the calculator? 0.5, then the natural log of 5 plus the square root of 73, then down here we have a 6. So this one gives us 0.407 to 3 decimal places. So x is equal to 0.407 3 decimal places. So that is going to be our answer. Number 2 is coming from modulus functions, but they are saying sketch the graph of y is equal to the modulus of 2x plus 3. So what you can do is to sketch the graph of y, which is equal to 2x plus 3 without the modulus, and then the part that goes beyond the x-axis, we reflect it in x-axis. Okay, so we shall have, I will put here my table values. I just need the x and y intercepts, okay? Only those. So when x is equal to 0, put the 0 here, y will be equal to 3. Then how about when y is 0? So when y is 0, you will bring this one here, it becomes a negative 3, then divide by 2, you get a negative 1.5, just like that. So meaning, I'm going to now draw my graph. So these are the axes here. So that is my grid. Now I'm going to plot 0, 3, 0, 3, which will be here, and then negative 1.50, which is here. So this means that I'm going to connect these two here, something like that. But there is a part that goes beyond this x-axis, so this one I'm not going to plot it. Instead, I'm going to reflect it here, okay? So you get your ruler again. Please use a ruler, not just a freehand, because these are straight lines. And then I'll reflect it there. I can even label this one as the positive part, because it was already above the x-axis. So 2x plus 3, and then this is the reflected part. So I can say y is equal to negative, or 2x plus 3. You know that if I have a coordinate here, this one is the x, then it has a y coordinate. But when I reflect it in x-axis, there will be an x here, same value, but y is going to change a sign, you see? So that's why I have negative of this, okay? The reflected function is a negative of that y. So that is that. It is optional to label them, okay? But it makes sense, especially where you are going to solve another equation using this graph. Like this part to be given here. Solve the inequality, 3x plus 8, then it is equal to this, what was given at first. So what I can do is to sketch this one here. I can sketch it on the same graph, and then I see which parts does this one here, y is equal to 3x plus 8, intersect. Does it intersect with this one or this one here? Okay. And when I do this, I don't need to test, because I can easily see what is intersecting. But if you split and you say this, then greater than the positive of this and also greater than the negative of this one, you will have to test, okay? Now I'm going to sketch this y, which is equal to 3x plus 8. So I just need two coordinates also to see where does it cut the x-axis and the y-axis. So if this is x and this is y, when x is 0, y will be 8. Then when y is 0, so bring the 8 here, then it will be a negative 8 over 3. And that will be 2.33 recurring, okay? 2.33 recurring, okay? Now I will come to this graph here. Actually, it will be a negative because 8 has crossed the signs, so it's negative that. Now I'll come to this and plot 0, 8, which is here, and then negative 3, negative 2.33, probably it is here. Okay, then I can draw, but I'm going to use maybe this green one. Okay, let me use the green one. So I'll draw a line that passes through 8 here, like this. So this one I can label it as y, which is equal to 3x plus 8. Okay, actually this one can continue because for it doesn't have the modular signs, so I can continue it down. Okay, now on the look of things, you can see that this line here intersects the reflected part. These ones are diverging, they will not meet. They can actually only meet this side, but yet we need only the positive part of this graph. So this one only intersects with this. So when you sketch, you can easily see that, and you don't waste time. You just pick out the parts that are intersecting. Okay, so I'm going to have this one here, the 3x plus y. It intersects the negative part of this modulus. See, then I solve this one accordingly. So we shall have here 3x plus 8 greater than negative 2x minus 3. So bring this one here. We shall have 3x plus 2x, then greater than negative 3, then minus 8. And we shall get 5x here, which is greater than 11, negative 11. Then when we divide through by 5, our x is going to be greater than negative 11 over 5. Okay, but again, also, so where they are meeting, it is negative 11 over 5. That is 2 point something. So when you check this value here, based on my sketch, it is below 2, but this one is 2.2, negative 2.2. Okay, let us assume this one is here. So what I'm going to do is to bend this one again. Okay, let me bend this one a little bit. Yeah, maybe something like that. I think that one is better. Then this region that we have gotten, this one means that this graph here has to be above this graph. So where it is above it, this is this value that we have gotten here is the negative 11 over 5. So we have to look at the right of it and the left of it. So on the right of it, you can see that the y value, this one here, this green one, this one is above this one here. You can see that it is down, so it is above. So we have to look at the right. So that means what we have gotten is correct, because it is greater than negative 11 over 5. So that is going to be our answer. However, you can also do the splitting. So when you do the splitting, you're going to test. So you consider one negative, you also consider the other one positive. Question 3, find the coefficient of x cubed in the binomial expansion of this one here. Okay, now what we are going to do is to first expand this one here using the binomial expansion. And binomial expansion states that a plus b to the power of n is the same as a power n, then b power 0 over 0 factorial. Now you keep dropping this power as you reduce it by 1, then b picks that power. So this will be n, then a power n minus 1, then b power 1 over 1 factorial. Then now n times n minus 1, then a plus n minus 2, then b power 2 over 2 factorial. The power of the b is the factorial we put down. Also plus, now drop this one here. It will give us n, then times n minus 1, then n minus 2, and then you have a to the power of n minus 3 now, then b power 3 over 3 factorial, like that. Okay, so now 1 plus 4x here to the power of a half. This one is going to be 1, then this one is to the power of a half, then you put 4x power 0 over 0 factorial, then drop the half, then reduce it by 1, so it will be negative a half, then this 4x picks that power, then it is to the power of 1, then we divide by 1 factorial, then plus, drop the negative a half, so we shall have a half times negative a half, and then this will be 1, then negative a half minus 1, that will be negative 3 over 2, and then this will be 4x, then squared over 2 factorial, and then we shall have, drop this one here, 1 plus 4x to the power of a half, So we shall have a half, then times negative a half, then times negative 3 over 2, then 1 here, power negative 5 over 2, and then this is 4x here, now power 3 over 3 factorial. So I'm going to stop here because they want the coefficient of x cubed, so I must go up to where x is cubed, because it will multiply, the 3 will have to multiply with that term. Okay, now here we shall get just a 1, and then a half of 4, that one will give us a 2x. Okay, and then here this is negative 1 over 4, which we get here, then times 4 squared is 16, but down here we are having over 2, so 16 divided by 8, that one will give us a 2, but it will be a negative. Okay, so we shall put negative 2x. How about here? We are going to have a negative times a negative, that is a positive. So we are going to have 3 here over 8, because it is 2 times 2 times 2. And then from there, times 4 cubed is 64. Then over 6 factorial is, 3 factorial is a 6, which is 3 times 2, if I may say. Then this one cancels that. 8 times 2, that is a 16. So 64 divided by 16, that one gives us a 4. So we shall have 4x cubed. And then from there, now this expansion 3 plus x into the square root of 1 plus 4x power half is the same as getting this 3 plus x. Then we multiply by everything here. Remember, this one continues, it's an infinite series, but we only end where they have told us. So 1 plus 2x minus, this is a squared, by the way, so 2x squared, then plus 4x cubed. So I only pick out the terms that end in x power 3. So the term in x power 3 is going to be this 3 multiplying with this. Okay, so I'll write 3, then times 4x cubed. Then this x here will multiply with the negative 2x squared. So I will say plus, then x times negative 2x squared. So this one will give us 12x cubed minus 2x cubed. And of course, this one will give us 10x cubed. And they want the coefficient of x cubed, which is 10. So I'll conclude by saying coefficient. Don't leave your answer here, because that is the term in x cubed. So coefficient of x cubed is going to be equivalent to 10. Then others, instead of writing the word coefficient, then they write x cubed is equal to 10. That is also wrong. Question 4 part A, show that the equation sin 2 theta plus cos 2 theta is equal to 2 sine squared theta can be expressed in this format here. Okay, now what I can do is, we are not seeing any double angles in here. So what is this one in double angles? It is 2 sine theta cos theta. Then this one is cos squared minus sine squared, okay, plus cos squared minus sine squared theta. Then this one I can actually bring it on the left side, and then I have minus 2 sine squared theta, which is equal to 0. Now here I have cos squared, which is here, then minus sine squared, then minus 2 sine squared will give me this one here, and then this one is this one, so it is already out. So I'll just conclude by writing it the way it is given. So we shall have cos squared theta plus 2 sine theta cos theta, then minus 3 sine squared theta, just like that. And that is our answer there. Okay, then next we have part B. They are saying hence sort of this equation. Hence. So we begin from where we have stopped. There are two methods I'm going to use to solve this one here. Okay. Let me just copy this one down so that I save time. So this is my equation here. Two methods. So let me even divide this into two. Now we shall have, I can divide all through by cos squared theta, because when I divide all through by cos squared theta, I'll get a tan squared here. Even here I will end up with a tan. So here I will have a 1, then plus, remember you have 2 sine theta cos theta, then down here you have cos squared is the same as cos theta, then cos theta. You see that 1 goes, and then minus 3 sine squared theta over cos squared theta. Of course, 0 over cos squared theta, that would be 0. So you have 1 plus 2 tan theta, then minus 3 tan squared theta is equal to 0. So when everything comes this side, we shall have tan now becoming positive. So 3 tan squared theta minus 2 tan of theta, then minus 1. This one is equal to 0. And I think this one is factorizable. Let's check and see. I'll press mod, then equation is 5, then 3, that is quadratic. So 3, then negative 2, and then negative 1. That is 1, and then negative a third. It is factorizable. So I will say tan of theta is equal to 1, and also tan of theta is equal to negative a third. I always leave space here to show the examiner that I've solved the equation. Okay, so if it wasn't factorizable, then I would have substituted in the quadratic formula. Just substitute in the quadratic formula once, then you write down those answers. But don't just write the answers like this and you proceed. You lose a mark. So cross multiply. This one will give us 3 tan of theta. Then when you bring this one here, it becomes a plus. So plus 1, which is equal to 0. Then bring this one here. Of course, that one is going to give us tan theta minus 1. So that is what we are having there. Now theta is going to be the arctan of 1, which is 45. Okay, we know that tan is positive in the first quadrant, STC. So this is 0, 90, 180, 270, then 360 degrees. So tan is positive here and here. See, so to get an angle in the third quadrant, I'm moving like this. So it will be 180, then plus theta. And then here, I'm having the same angle theta. I can also project it here, theta. Then this one will be, you move up to here like this. This one is going to be 360 degrees, then minus the theta. Then to move from here up to here in the second quadrant, it will be this 180, then minus the angle you are getting here. Okay, so we have 180, then minus theta. So this one is going to give us 45 degrees. Okay, now the next angle where tan is positive, it is going to be in the third quadrant here. So I can get 180 plus the 45, but based on the domain given, the domain just ends on 180. Okay, so I'm not going to get the other angle. Then how about this one here? Theta is going to be equal to the arctan of negative a third. So one answer is this one here, negative a third. Now we go to the quadrants where tan is negative. Tan is negative in the second quadrant and in the fourth quadrant. Okay, so what we can do, but when you put this one in the calculator, it is going to give you negative that angle. It is only a cosine. You get the arc cos of the cosine, and then it gives you the obtuse angle straight away. But this one is going to give me the negative acute angle. So what do I do in that case? I'm going to ignore the negative, and then I get the arctan of a third. It will give me the acute angle here. After getting that acute angle, I will come here and subtract it from 180. So this theta is going to be 180 degrees minus, what do we get when we get arctan of a third? And your calculator has to be in degrees. Now shift, then turn here. We shall have a third. Now suppose I put a negative. Do you see that the answer is a negative? Okay, so you just come here and you say 180 minus 18.4. When you ignore the negative, it gives you that positive answer. So you come here and then you subtract it there. And when we subtract, this one gives us 161.6 degrees. That is to one decimal place. So that is that. Alternatively, this one requires a lot of thinking. Okay, the cos squared you are having here, let me just bring it here. This equation here, since this one is a square and this one is a square, I'm going to take it as a quadratic. Okay, and I factorize out. So what is here, the two numbers that I can multiply to give me -3, but when I add them they give me 2. I have -3. Okay, -3, I mean +3, and then -1. When you add them, they give you the 2. You multiply them, they give you this -3. Now, that means here, I'm going to substitute these two values in the place of this one. So you can have cos squared theta, then plus 3. Can write, let me begin with the negative. So minus sine of theta cos theta, then plus 3 sine theta cos theta, then minus 3 sine squared theta, which is equal to 0. Now what is common here is the cosine, so I factorize it. Cos of theta, then here we shall have cos theta minus sine of theta. Then here what is common? We have 3 sine theta. That means we are remaining with cos of theta here, and then here we shall have a sine theta, which is equal to 0. So what is common? Cos theta and sine theta. Now I will have cosine of theta minus sine theta, then times, this is cos theta plus the 3 sine of theta. I can equate each of these factors to 0. Okay, and what should we have here? When I equate this one to 0, this one here minus sine of theta is equal to 0. You have cos theta, which is equal to sine theta. You can now divide all through by cosine of theta. But what do you get here? 1. Then here tan of theta. So meaning theta is going to be the arctan of 45. Arctan of 1. Then theta becomes a 45 degrees. Okay. Then we also got the other one, cosine of theta plus 3 sine of theta is equal to 0. We can divide all through by cosine of theta. Let me take this on this side. So we have -3 sine of theta, then we divide it by cosine of theta. So this is 1, and then -3 tan of theta. Then when we divide through by -3, tan of theta is going to be equal to -1/3. You see that? So theta is going to be the arctan of negative a third. So do you see that you still get the same answer, 161.6 degrees? That is that. Question 5, the equation of the curve, this one here, where a is a non-zero constant. Okay, show that dy dx is equal to that. This is implicit differentiation, so I'll get this and I differentiate it with respect to x. So I'll have d dx, then you differentiate this one, then minus, I can have d dx a y squared, then also here d dx, then we have 4a cubed. Now this is a product of two functions, so I'm going to use the product rule. So I will have x squared constant, then d dx of y, then plus y constant. Now we differentiate x squared, then minus, I can actually pull out this a because this is just a constant. I can write it here as a, then d dx of y squared. Okay, then automatically this one will give us a 0 because this is a constant. They said a is a non-zero constant, so if it multiplies with the 4, I have a constant there. Okay, now when I'm differentiating, because y is a variable, when I'm differentiating any function in y, okay, let's say this y squared with respect to x, okay, I'll first differentiate this y squared with respect to y, then from there I multiply by dy dx, because it is like I have done nothing, because this one can go, and then I remain with my d dx of y squared. So you see that? So when we differentiate this one, it will give us a 1. So we shall have x squared, then times 1, then dy dx. You have to multiply with the dy dx. Then plus, when I differentiate this one, it will give me 2x. So 2x, then times the y, that is 2xy, minus, here we shall get a, then times, when I differentiate this one, it gives me 2y, then I multiply it by dy dx, which is equal to what? 0. Okay, then I'm going to factorize out the dy dx. In fact, I can take them this other side. So we can have, this is 2ay dy dx. Then when this one crosses, it will be minus x squared dy dx. Okay, then this one will be equivalent to 2xy. Okay, so factorize out the dy dx. So dy dx here, we are going to have 2ay minus x squared, then this one will be equivalent to 2xy. So when we divide all through by this coefficient of dy dx, our dy dx is going to be equivalent to 2xy out of 2ay minus x squared. So that is what they told us to show. Next, hence find the coordinates of the points where the tangent to the curve is parallel to y-axis. I even talked about this, I think in October, November, paper 3-2. I must have talked about it. So what you do, you just get your axis here. Just draw something small, just like this. Okay, I have, let me draw a better one, using a ruler. I have these two axes, and then the line is parallel to y-axis. Any line which is parallel to y-axis is vertical. So just like that. Then I will have, this one is my y, this is 0. So on this line, this is x-axis. Okay, on this line, we are having an x coordinate and then a y coordinate. Let's say this is y2. And then there is another point here, the same x coordinate, and y is different. Okay, now when we are getting the equation, I mean the gradient here, the gradient, remember, is change in y over change in x. So the change in y is there because y2 is different from y1, but the change in x minus x is a 0, and this one here is undefined. Okay, so any line that is part of the y-axis has an undefined gradient. So what do? We get the denominator. Okay, get the denominator of dy dx, which is the gradient function, okay, and equate it to 0. Equate it to 0, because any number divided by 0 is undefined. Okay, so we shall go to our dy dx, which is this one here. So I'll get the denominator, this one, 2ay minus x squared. It is the one that I'm going to equate to 0. So we shall get 2ay minus x squared is equal to 0. So meaning 2ay is equal to x squared. I can express y in terms of x. Okay, so when I express y, let's check again. I'm supposed to substitute in the equation which was given here for the curve. So x squared is there. Okay, if there is x squared, then I can actually just take it like that. So we have x squared y minus a y squared, then is equal to 4. So substitute in here. We have x squared y minus a y squared, then is equal to 4a cubed. So we are going to have x squared is 2ay. So 2ay, then times y, then minus a y squared is equal to 4a cubed. Okay, so this one will give us, this is 2ay squared minus ay squared. Don't you think we get ay squared, which is equal to 4a cubed? Okay, now divide through all by a, we shall get y squared, which is equal to 4a squared. Okay, then to get y, we shall take the square root of 4a squared, and this will be plus or minus. So y is going to be plus or minus 2a. Okay, plus or minus 2 of a. And they said find the coordinates of the points. That means it is more than 1 point. Okay, so we have to get the x values for which y is a positive 2a and also y being a negative 2a. So you can say for y, which is equal to the positive 2a, what is x? X is going to be the square root here, the square root of 2ay. Okay, so we can put the square root of 2a and the y is 2a. Okay, so what are we having here? This one is going to be, of course, 2a, because you have 4a squared there. So if you have 4a squared, root of that, that will be 2a. Now when we take the square root, of course, we are supposed to have plus or minus. Okay, we are supposed to have plus or minus. So that means what I'm going to get here is plus or minus 2a. So I'm going to have the two coordinates here. I'm going to have one is positive 2a and then 2a. You see, that is 1. And then there's 2a here, but there's also negative here. So I'm going to have negative 2a, the x coordinate, the y coordinate is 2a here. That is another one. And then for y is equal to negative 2a, because this is plus or minus. Okay, so when I take the minus, our x, remember, it has to be plus or minus the square root of 2a, then times y. Now this is a negative, so you are going to get plus or minus the square root of negative 4a squared. So this one is undefined because this one has to be real. Okay, it's undefined. So here we are not getting a solution. So our answer the two answers we are supposed to have are this and this. Question 6. Relative to the origin O, the points A, B, and C have position vectors given by these. The quadrilateral ABCD is a parallelogram. Find the position vector of D. Now, a parallelogram, you have to follow that direction there. Okay. If they say A, B, C, D, follow that. So we can have A can be here, then B can either be here or here. Okay. So if I have my B down here, then this is C, then D will be here. Okay. This one here is parallel to this, and then this one here is parallel to this one here. All right. So they said that find the position vector of D. Parallel vectors, they are scalar multiples of each other, but also on the parallelogram, this side here, AD, is equal to this side here, BC. So I'm going to use vectors, and I say that AD is actually equal to BC. So you don't waste time here. You just get the last one. To get AD is OD minus OA. Okay. OD minus OA. Then this one here is going to be OC minus OB. Okay. Why am I doing that? A to D, let me say my O was here. So this is O to D, this is O to A. I want to go to D. So I will say AO. Do you see that I'm moving in the opposite direction? So this one will be negative OA. And then plus this, which is positive. So you just use the negative, get the last minus the first. As simple as that. Okay. Now, that means our OD is going to be equivalent to, take this one this side, which is going to be OA, then plus the OC minus the OB. And all of these ones are given. So OA is 2, 1, 3. Then OC is 3, negative 2, negative 4. Then OB is 4, 3, and 2. So what is OD? OD is going to be 2 plus 3, that is 5, minus 4, we shall get a 1. Then 1 plus negative 2, that is a negative 1. Then minus 3, that one will be a negative 4. Negative 4. And then 3 plus negative 4, that will be negative 1. Then minus 2, that will be negative 3. So I will have negative 3 here. So this is the position vector of D. Okay. Alternatively, you could even use this one here, because we have two parallel sides. I have to show you all the alternatives. So alternatively, I can have AB here is equal to DC. Okay, so I say AB is equal to DC. Now, do you see that even this one, we are going to have OB, the last minus the first one. Okay, even here, OC minus OD. Now, I can bring this OD to this other side such that it becomes a positive. Okay, then I take these ones this side. Okay, so OD comes this way, it is a positive, then is equal to take the OA this side, it is going to become a positive, right? Then it finds there the OC, which is positive. Now take the OB this other side, it is going to be a negative, so minus OB, just like that. Don't you see that what we are having here is exactly what is here? OA plus OC minus OB. So that is that. Then you proceed the same way we have done this. So that is that. Part B, the angle between BA and BC is theta. Find the exact value of cosine of theta. Okay, so let me say this is my A, then to B we had drawn something like that. That is A, then this is B, then this is C. So this is theta here. Okay, you can do two things: either close in, so A to B, and also B to C, I mean C to B, or you can open up from B to A, then B to C. So use what you want. Okay, so here I can find BA. BA is OA minus OB, right? So what is our OA? Is 3, no, it is 213, and then my OB is 432. When I subtract them, we shall get -2, -2, and then 1 here. Then BC. BC is OC minus OB. So OC is 3, -2, -4. Then OB is 432. When we subtract here, we shall get -1, here -5, and then here -6. Okay, now having gotten those two vectors, since here we are talking about an angle between two vectors, then I'm going to use the scalar product, okay, or the dot product. So using the scalar product, we are going to have BA, we dot it with BC, then this one is equal to the modulus of BA times the modulus of BC, then cosine of the angle in between them. Okay, so what is BA? We are going to get -2, -2, 1. We dot it with BC, it's -1, -5, -6. And then here it will be square root BA. This is -2 squared, then plus -2 squared, then plus 1 squared, then times the square root of -1 squared plus -5 squared, then plus -6 squared, then the cosine of theta. Okay, so -2 times -1, that one will give us a 2, then plus a 10, okay, in the middle here, and then 1 times -6, that is -6. So this will be 4 plus 4, that is 8, then plus 1, that is 9. So root of 9 gives us a 3. And then here we have 25 plus 1, that is 26. Then 26 plus 36, that one gives us 62. So we shall have root of 62 here, cosine of theta. So cosine of theta is going to be equal to, and this is 12 minus 6, that one will give us a 6. So I'll write 6 here, then I divide by 3, root of 62. Okay, and of course this one can go here 2 times, then I can simplify it as cosine of theta is equal to 2 out of the square root of 62, or you can write 2 root of 62 over 62, because you can multiply root of 62 here and also here. Okay, and then you can also simplify this, and then you put a 31 down here. So all of those are possible answers, but I'm going to leave mine just like that. So this is my value, and they said exact, so we don't need the decimals, it has to be in the third format. Then next they are saying, hence find the area of ABCD, giving your answer in this form. Now a parallelogram, if I may sketch it again here, allow me to do a simple sketch here. this parallelogram A, B, C, and D, we have found this angle theta. This parallelogram has gotten two triangles. Okay, I can even dot this line here that I'm passing through here. It has gotten two triangles. So that means I can get area of this triangle, which is the same as the area of that triangle, because those two are congruent. Then I multiply it by 2. Okay, and to get the area of a triangle which is not right angled, all I need is to get this length here, AB, and then BC. So after getting that, then I'm going to use a half times that length AB times the length BC, then sine of the angle in between them. Okay, so that is going to be that. Now sine, I don't have sine of the angle, but I have cosine here, and we know that sine and cos are connected. I can use the Pythagoras theorem, or I can use the Pythagorean identity. Okay, so if I have this triangle here like this, and this is theta, cosine is adjacent, so adjacent is 2, then the hypotenuse is root of 62. So for me to get what is here, I'll get the hypotenuse squared, okay, then minus the adjacent squared. So what do we get here? Of course, here we shall get 62, then minus 4, that will be 58. So we shall have root of 58. Or another person can say that sine, before that, sine of theta is going to be the opposite we have gotten here over the hypotenuse, root of 62. So alternatively, another person can say if sine squared is equal to 1 minus cos squared, then that means sine of theta is going to be the square root of 1 minus cos squared of theta. So I'll have the square root of 1 minus cos, the cos is 2 over, then root of 62, then we square it. So when we put this one in the calculator, what do we get? Square root of 1 minus, we have 2 out of square root of 62, then squared here. So it is square root of 899 out of 31. But this one is the same as saying, by just simplifying it manually here, I will have the square root of 1 minus, this is 4 out of 62. So you multiply with this one here, you will get 62. So 62 minus 4, you will get 58. So I'll have the square root of 58 out of the 62, which is the same thing we have up there. You see? So that is that. Now let's continue with our calculation. So the area of parallelogram, I said it is going to be 2 times area of one of the triangles, area of, let's say, triangle ABC. Okay, and this one is going to be 2 times a half times AB, then times BC, and then sine of theta. Okay, so of course this one will go, and then we shall have AB. Have we got an AB up there? AB as a length. This is BA and AB are the same when it comes to the length. So it gave us a 3. Okay, so I'm just going to put a 3 here. Then BC, we got it here. Also BC. So the length is this second one here, which is root of 62. Okay, root of 62. So I'll just multiply with root of 62 here. Then sine of theta is this one here. So I'll write root of 58, then divide by root of 62. So do you see that root of 62 is going to cancel with this? So when it cancels, then we are going to remain with 3, the square root of 58, as our final answer. And they say that we should write our answer in this format. This one here. So our P is 3. Then our Q is the number under the square root, which is 58. Okay. So that is that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next video.